The difference between two numbers is 3, and their sum is 19. What are the numbers? To start, we will let the two numbers be x and y. The difference between the two numbers is 3, therefore, x minus y equals 3. The sum of the two numbers is 19, therefore, x plus y equals 19. We now have two linear equations, which we can solve simultaneously. There are two basic ways to solve a pair of linear equations simultaneously: elimination or substitution. We will start with the elimination method. The objective of this method is to eliminate one of the variables, either by adding or subtracting the two equations. Since the coefficient of y in the first equation is -1 and +1 in the second equation, we will add the two equations, since doing so would eliminate the variable y. So, adding all the terms of equation 1 to those of equation 2 gives us 2x equals 22, and therefore x equals 11. In order to determine the value of y, substitute this value of x into either of the equations. It doesn't matter which equation you choose to substitute into. Y therefore equals 8. The second method of substitution involves isolating one of the variables from one of the equations, and then substituting this expression into the other equation, and solving for the relevant variable. Isolating x from the first equation gives us x equals y plus 3. We now substitute this expression into the second equation and solve for y. Y therefore equals 8. And to determine the value of x, substitute this value of y into either of the original equations. X therefore equals 11. You should always check your work. The difference between 11 and 8 is 3, and the sum of 11 and 8 is 19. The sum of three consecutive, even numbers is 48. What is the smallest of these numbers? Word problems are very easy once a mathematical equation has been formulated, which can then be solved. The formulation of an algebraic equation requires solid knowledge of fundamental mathematical concepts. There are certain key words inherent in a word problem that need to be translated into mathematical constructs. In this problem, those key words are sum, consecutive, and even. Sum implies addition. Consecutive means one after the other. And an even number implies doubling any number. Before we write down an expression for an even number, consider the first 10 natural numbers. Starting at 1, which is odd, the next number 2 is even, 3 is odd, 4 is even, etc. The odd and even numbers therefore alternate every second number. If we take any natural number, regardless of its value, and we double it, the result will be an even number. For example, 2 times 2 is 4. 2 times 3 is 6. 2 times 9 equals 18. 2 times 23 equals 46, etc. So, if we take any number, let's call it x, and double it, we will get an even number. Thus, an algebraic expression for an even number is given by 2x. Now, consecutive implies one after the other. A synonym for consecutive is successive. Since the odd and even numbers alternate every second number, the next even number after 2x must be 2x plus 2. And the even number after that is 2x plus 2, which equals 2x plus 4. The sum of these three consecutive even numbers is 48, therefore, 2x plus 2x plus 2 plus 2x plus 4 equals 48. We now have a simple algebraic linear equation, which we can solve. Collecting like terms, with the variable on one side of the equation and constants on the other, gives us 6x equals 42, which means x equals 7. You should always check your work. So the first even number is 2 times 7, which is 14. The next even number is 2 times 7 plus 2, which is 16. And the next even number is 2 times 7 plus 4, which is 18. 14 plus 16 plus 18 equals 48, which validates the solution. If you are unsure about anything we have just done, or just want to refresh your memory, these are covered in detail in the workbook and in the online courses, the links of which have been provided in the description box below. A father is 3 times as old as his son. 6 years ago, he was 5 times as old as his son. How old are they now? First, we will let the smaller quantity, which in this case is the age of the son, be x. The current age of the father is therefore 3x, since we are told that the father is 3 times as old as his son is now. 6 years ago, the father was 5 times as old as his son then, so we also need to find an expression for each of their ages 6 years ago. Since the son is x years old now, he was x minus 6 years ago. Likewise, the father was 3x minus 6 years ago. We now need to equate these two expressions. We are told that 6 years ago, the father was 5 times as old as his son. So, whatever the son's age was 6 years ago, we multiply it by 5, and equate it to the father's age 6 years ago. In other words, 3x minus 6 equals 5 times x minus 6. This is now a linear equation, which we can solve. Taking all variable terms to one side, and constants to the other, and solving, we get x equals 12. It is strongly advised that you check your work. The son is currently 12 years old, which means that his father is 36. 6 years ago the son was 6 years old, and the father was 30. 30 is 5 times 6, so the solution is correct. The combined age of a father and a son is 84 years old. In 6 years' time, the father will be twice as old as the son was 3 years ago. How old are they now? Whenever given an age problem like this, it is a good idea to draw up a table and let the smallest quantity equal x. In other words, since the son is obviously younger than his father, we will let the son's age be x. We are also required to determine the age of the father now, so we will let the age of the father now be y. In 6 years' time, the son will be x plus 6, and the father will be y plus 6. Similarly, their respective ages 3 years ago are x minus 3 and y minus 3. We are told that the combined current ages is 84, therefore, x plus y equals 84. We are also told that in 6 years' time, the father will be twice as old as the son was 3 years ago. In other words, y plus 6 equals 2 times x minus 3. We now have two linear equations relating x to y, which we can solve simultaneously. So, isolating y from the first equation gives us y equals 84 minus x. Now, substitute this expression for y into the second equation and solve for x. The current age of the son, x, is therefore 32. That means that the father is currently 52 years old, since their combined current ages is 84. You should always check your work too. The father will be 58 in 6 years' time, and the son was 29 3 years ago. 58 is twice 29, which means the solution is correct. The problem can also be solved by using only one variable. Again, we will let the son's current age be x, which means that the age of the father now is 84 minus x. In 6 years' time, the father will be 84 minus x plus 6. Since the father's age in 6 years' time will be twice the son's age 3 years ago, it follows that 84 minus x plus 6 equals 2 times x minus 3. Solving for x gives the same solution. The current age of the son is 32, and the father is 52. If you liked this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.